Hello, welcome back for one more installment of partial fractions. So if you get out a blank piece of paper, I'll show you how to do the last part to the partial fraction stuff, and then you should be able to do that whole partial fraction assignment. So you can label this even more integration using partial fractions. You can think of this as day 3 if you want. Okay. So let's start out with one example like yesterday, so you remember what we've been doing. Let's say I wanted you to integrate 5x squared plus 2x minus 1 all over x plus 2 times x minus 3 squared dx. Okay, so the difference with yesterday was when we had repeated linear factors. So x minus 3 happens more than once. So if I wanted to rewrite and break up this fraction, we could say 5x squared plus 2x minus 1 over that denominator, x plus 2 times x minus 3 squared, could be some constant over a fraction with x plus 2, but you can't just say plus b over x minus 3 squared, because it could be a fraction b over x minus 3 and another fraction c over x minus 3 squared. Now, in all these that we've been doing, we've been assuming that we've been making these fractions kind of in simplest form. And what I mean by that is if this is a degree 1 denominator, then on top I can have a degree 0, which is just a constant. Today we're going to talk about what happens when the degree on the bottom is degree 2. But we'll get into that in a second. Okay, so remember, any piece that's repeated, you have to have every iteration of that up into the maximum number that there are. Okay, and now if I wanted to get common denominators, we could say that this first fraction, the numerator, would have to get multiplied by both x minus 3 terms. The second fraction would need the x plus 2, but it would also need one of the x minus 3 terms. And the third one has both x minus 3 terms, but it needs x plus 2. Now again, I'm obviously doing that top and bottom, so that would all be over this denominator. But when I add these together, this top would have to end up equaling 5x squared plus 2x minus 1. All right. Now from there, we want to pick values that are going to make it easier for me to figure out what a, b, and c are. And this is true for any x value, so be smart about what you pick. If I pick 3, then this term's going to go away, and this term's going to go away. So let's let x equal 3. Then my left side becomes 5 times 3 squared plus 2 times 3 minus 1. And that's going to equal a times 3 minus 3 squared plus b times 3 plus 2 times 3 minus 3 plus c times 3 plus 2. What's that give us? Well, this is 9. 9 times 5 is 45. Plus 6 is 51. Minus 1 will get us to 50. That term's gone. That term's gone because there's a 0 getting multiplied. And I've got 5c here. So right away I have that c is 10. All right, what's another number that's going to help me? Negative 2, because both of these terms will go away. So let's let x equal negative 2. So you'll have 5 times negative 2 squared plus 2 times negative 2 minus 1 equals a times negative 2 minus 3 squared plus b times negative 2 plus 2 times negative 2 minus 3 plus c times negative 2 plus 2. So what's that give us? 4 times 5 is 20, minus 4 is 16, minus 1 is 15. Now this will be negative 5 squared, so that's 25a. Negative 2 plus 2, that term's gone, and that term's gone. So when you divide 15 over 25, it's the same as 3 over 5. So it's okay if these constants come out as fractions. Won't really change things much. All right, so I've got a and c. I've still got to find b. So again, I can use any x value I want. We used these two because that would get rid of terms. What's the easiest x value I haven't used yet? Def 0. So let x equal 0. Then I would have 5 times 0 squared plus 2 times 0 minus 1 equals a times 0 minus 3 squared plus b times 0 plus 2 times 0 minus 3 plus c times 0 plus 2. What's that give me? Well, I've only got negative 1 over here. This would be 9a plus 2 times 3, so 6b, plus 2c. But then remember what you already know. You know that c is 10. You know that a is 3/5. So you can plug those in also and then solve for b. I might remember yesterday we needed matrices. That doesn't come into play here. This is just going to be 27 over 5 plus 6b plus 20. Okay, so let's solve this. Yeah, let me grab my calculator here. All right, here we go. If I do negative 1, I'm going to subtract the 27 over 5. I'm going to also subtract the 20. So that gives me that equals 6b, so then I divide by 6. And let's make it a fraction, because fractions are friends. Negative 22 over 5 equals b. Oh, 1 second. Quick correction, that was a minus here. So it's actually a minus 6b, sorry. So instead of negative 22 over 5, it's going to be positive 22 over 5. But you probably all caught that already. Right. Okay, so now I know what a, b, and c are. I can go back and integrate now. Okay, so this original problem becomes the integral of 3/5, that was my a value, over x plus 2 dx, plus the integral of 22/5 over, what was my b fraction, x minus 3 dx, plus the integral of 10 over x minus 3 squared dx. Okay, so with all of these, remember the constants can get pulled out front. So this will be 3/5 times, when you have just x plus 2 in the denominator, if u was x plus 2, the derivative would just be 1, so there'd be no extra number coming out front from u sub. 1 over u is ln, so this is ln of the absolute value of x plus 2. Similarly, the second one's going to turn into 22/5 times the ln of the absolute value of x minus 3. Now the last one, we can pull that 10 out front, but then think about what's happening. So this would be 10 times the integral of 1 over x minus 3 squared dx. Don't just jump to ln because there's a squared here now. So now if you let u equal x minus 3, the derivative is still 1. So this would turn into the 10 times the integral of 1 over u squared du, or 10 times the integral of u to the negative 2 du. And when you add 1, this is just power rule, it'd be 10 times u to the negative 1 over negative 1. So it's negative 10 over u, which was x minus 3. So this last term actually becomes a negative 10 over x minus 3, and then don't forget your plus c. Okay, so just be careful. It's not always going to be ln. It's only ln if it's a first power on the denominator. When it's something else like this, we've got to do u sub with power rule. Okay, so that's where we were at the end of yesterday. The last type that you'll need to do that assignment is when there's an unfactorable quadratic. So today's new piece is unfactorable quadratic in denominator. So let's say I wanted to integrate this. The integral of 2x squared plus 5x minus 8 all over x minus 2 times x squared plus 1 dx. So when I look at this denominator, I have a linear term, which is fine. But then this x squared plus 1, it's a quadratic because it's x to the second power, and I can't factor it, at least not over the real numbers. So this is what I mean by an unfactorable quadratic. Okay, so this is how I have to deal with it. We can still split up the fraction, but it's a little bit different. 2x squared plus 5x minus 8 all over x minus 2 times x squared plus 1 becomes a over x minus 2, that part's normal. But then the second fraction, since I have a quadratic on the bottom, x squared plus 1, the numerator is bx plus c. And I mentioned briefly on the front, we're assuming these fractions can be split up into simplest form fractions, meaning that they are still fractions. They're not improper fractions. There's not a bigger piece on top than the bottom. So when I have degree 1 on the bottom, I can have degree 0 on top, which is just a constant. But now, when I have degree 2 on the bottom, we have to have, or we could have degree 1 on top. It's possible there's an x term on top also. It's possible there's not. In that case, b would be 0. But we have to take it into consideration that it could be like that. Okay? So we do the next step much the same way. We're going to get common denominators. So when I get common denominators, we'll add these across, keep the denominators the same, so the denominators kind of won't matter. But the numerator needs to equal 2x squared plus 5x minus 8. This first fraction is going to need to get multiplied by x squared plus 1. So a will get multiplied by x squared plus 1. And this second fraction, bx plus c, the whole numerator, has to get multiplied by what? X minus 2. Okay, so in this case, picking values for x aren't going to help quite as much. I might be able to find an a value because I could pick x equals 2. But if I pick x equals 2, this piece will go away. This piece won't, so I could find a that way. I'm still going to have a problem with b and c. So when it's like this, I'm going to take you on a little bit different of a strategy. Let's actually multiply these out. Okay, so we've got 2x squared plus 5x minus 8 Let's multiply this out. It's ax squared plus a if you distribute. This you can either box or FOIL, whatever you want to do. If you box it out, you'd have bx plus c and x minus 2. This would be bx squared cx negative 2bx and negative 2c. So we'll have plus bx squared minus 2bx plus cx minus 2c. Now, why do I write it out like that? Well, you know how like terms work. So if I'm going to end up with 2x squared, that has to come from ax squared plus bx squared. So in other words, for my x squared term, 2 has to equal a plus b. Because the only way this is going to become 2x squared is if a plus b equals 2. Okay, now look at your x term. 5x, that has to come from negative 2bx plus cx. So for my x term, 5 has to equal negative 2b plus c, because the only way that this is going to become 5x is if negative 2b plus c combine to give me 5. All right, and then lastly, negative 8, the constant, has to come from, let's use a different symbol here. The constant has to come from a minus 2c. So negative 8 has to come from a minus 2c. Those have to combine to give you negative 8. Okay, well, what do we have? Well, that's 3 equations with 3 unknowns, a, b, and c. How can I solve 3 equations with 3 unknowns? You can solve a big long system of equations, or you can use matrices. So let's say this is my A column, this is my B column, this is my C column. So for the first, the blue equation, A plus B equals 2, 1A plus 1B plus 0C equals 2. For the green equation, there's no A's, but negative 2B plus 1C equals 5. And for the third equation, 1A, there's no B's, but minus 2C's equals negative 8. You can plug that into that calculator and then do reduced row echelon form. So remember how to do this. You go to second matrix, edit, use A again. This time it's a 3 by 4 matrix, which mine's already set up to be. Then I can start typing in 1, 1, 0, 2, and then 0, negative 2, 1, 5, and finally 1, 1, 0, negative 2, negative 8. Okay, once I've got that all locked in, I can second quit, get out of there, then go back to your matrix menu, go to Math, find all the way down to Reduced Row Echelon Form. I think it's A or B. It's B. And then you want a Reduced Row Echelon Form on matrix A. And what we come up with. There it is. So just copy that down. We've got 205. So we got 1, 0, 0, 2, 0, 1, 0, 0, and 0, 0, 1, 5. So this first row literally tells us that 1a equals 2. Second one tells us that 1b equals 0. The third row tells us that 1c equals 5. Okay, so finally we can integrate. So this original integral turns into the integral of a, which is 2 over x minus 2, plus the integral, dx, plus the integral of, there's no b term, so that's 0. C was 5, so 5 over x squared plus 1 dx. And all I have to do is integrate both of those. Well, this first one will be easy. The 2 will come out front. Then it's just a constant on the bottom, or sorry, first degree on the bottom. So u would be x minus 2, d over dx is just dx. So nothing weird that's going to come out front or anything like that. And you'd have ln of the absolute value of x minus 2. Okay, but for the second one, anyone recognize what that is? It's not a u sub. What if I pull the 5 out? 5 times the integral of 1 over x squared plus 1 dx. What is that? Well, usually we see this as 1 plus x squared on the bottom, but that is the integral of tan inverse of x. So we've got 5 tan inverse of x plus c. And that's it. Okay, you now know everything you need to know in order to do this assignment. So I told you after yesterday's video you could do everything except number 7, which is that unfactorable quadratic. Now you can do number 7. And on the back there's 2 bonuses. I try to give you some hints, so read through the hints and then try to answer those questions as well. And this counts as a take-home test grade. So work through this. If you have any questions, be sure to ask me. Good luck.